Welcome back, friends. I've made a huge mistake. Let's just have a look at this this weirdness that's going on. Let me just get OBS correct. There we go. So I remember we stopped on this last time. I didn't really get it. Didn't really understand the full thrust of the argument that was presented. Some shit on my screen now. What the fuck? I just noticed that my my Windows bar is purple. Same purple as Visual Studio. Is that by design? Anyway, function pointers. I don't get how to assign them apparently. Let me just grab my Monday keyboard. Let me just destroy everything in my path. Hold on. Very good. When we use the name of a function as value, the function is automatically converted to a pointer. For example, we can assign the address of length compare to pf as follows. Pf equals length compare. Bah, boom. Right. Okay. So what was I doing here? We got a int calc. All right. Oh, right. Okay. Do you know what? Do you know what? I think the problem is because we have this going on. We have this going on, which was from the week before, the week prior, which was all about what do you call it? Slams. It was all about function. I can't remember the word, but where you have function overloads. So you have a function defined with multiple arguments, and that then the compiler, as it goes through your code, will select the correct version of your function to use at each appropriate juncture. Yes, and I think function overloading is perhaps in direct conflict with using pointers to functions, because when you have pointed to a function, this compiler, at least this IDE, does not like that. It says you haven't specified which function. I remember that happening. Hey. So we've got a type def here, which we might not need. Let's keep that in. Okay, let's make a new function. Let's nuke everything that we did last week. So we don't even need a function body really. We know stuff would go into a function body. It would just be like, you know, in Jimmy there we go. So we can get rid of all that. You can get rid of all that. We can get rid of all that. Can close up all that. Close up all that. Comment this out. Don't need you anymore. Scoot you away. So now we have Jimmy. Yes. I wish it would not expand when the cursor moves to the location. Very angry that makes me. Very angry. Do you like the Halloween? Do you like the slathering of Halloweens that we've got here? That is consuming 70% of the GPU. This is why we can't have nice things. Unreal 4.25 doesn't work that well, does it? It's got Niagara and everything, but it doesn't like the actual thing. So we've got it in Jimmy. Okay, so the first way we can do this. The first way we can do this is by making a pointer called tool to a function that returns an int and takes 2 ints. Epic slam. That's fine. It's uninitialized. Beware, it's uninitialized. So now we can do tool equals 0. That again, it's a null. That's a null pointer now, right? Fine. I'm okay with that. I'm beautiful with that. Then we can do tool equals Jimmy, which will set tool to the function Jimmy. And then we can use Jimmy tool and star tool interchangeably. Thumbs up. Oh, here it is. How did I not see this? As usual, when we use an overloaded function, the context must make it clear which version is being used. When we declare a pointer to an overloaded function, Aha, here we go. So we've still got calc out, which doesn't do anything as well. So we can do int star ncalc brackets char star equals calc. And that works fine. Beautiful. Absolutely fantastic. You see, the power that you gain simply by using your eyes to read the page. Impressive. Right. So what's this type def bullshit I was getting entangled with? How did I not do this? You know what I think happened? I think I swiped to go down the page, and I think maybe, just maybe, Acrobat Reader on my phone decided to ignore the swipe and just ignore animating that and skip me a couple of pages ahead. Thanks. Another reason why I'd like a beautiful, beautiful e-reader, but they sold out. I went to buy the e-reader at the start of this month. Sold out. Big sad. So, just as with arrays, we cannot define parameters of function type, but we can have a parameter that is a pointer to a function. As with arrays, we can write a parameter that looks like a function type, but will be treated as a pointer. Right. Okay. So when you're writing a function and you need a function parameter for some reason, I don't know why you need a function parameter. If anybody out there, literally, I know people watch these videos, and I'm getting in early now. This is, we're only at the 10-minute mark. Any of you boys on YouTube, sorry Twitch, you're not engaged with this media, I know. Maybe I should just record these as offline videos. Then I won't have to be online. I could stream something else. Interesting. Good thought. Bad thought. Oh. Well, it's not like you're coming to watch. It's not like you're coming to watch these videos anyway. You wouldn't. Anyway, that's something for me to wrestle with. Interesting. So if anyone's out there knows a time where you would need a function as an argument to another function, please let me know, because I can't think of a time where that would need to happen. Like, because especially if you define your functions in a header file, all of your functions are going to be in scope in your main file, in your C file, right? So is it not entirely reasonable to say that if you require the use of a function within a function, you can just simply call it as it will be in scope, right? It's like using printf in a function, because printf itself is already a defined function in the C library, and you're using the library, right? Am I right? I'm right. I know I'm right. I got that feeling like it's going to be some stupid edge case, which is what this is used for, and it's not going to be anything remotely useful to a beginner programmer like me. Watch it be really critical. So when you define the function, you write the prototype in the list of parameters. So you'll write the definition essentially of the pointer. And then when you call the function, you can just write the function name. Right. Okay, so I get that we're using declaration type. Declaration type? Decl type? However you want to pronounce that, okay? We're using that to shorten the name of the function definition in the function definition. This is why no one wants to learn C anymore. Stupid. And okay, so we're using that to shorten the declaration. We're using that to create a pointer to a function type, right? Wait, no, stop. No, stop. Wait, no, stop. What? So, hang on. No, 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 no. No, 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 no. Stop. Right. Okay. Stop. Both declarations declare the same function. So we got void, use bigger, const string and, func. Func being a function. A declaration type, function type. And we have void, use bigger, const string and, func p2, which is pointed to a function type. So C, in the compilation area, the compiler will automatically convert the function type represented by func to a pointer. So actually, did we need to go around the houses and use declaration type to create a function type name when we could just use the function? I want to understand, but like sometimes there's just like a gap of knowledge. So we gotta void Jimmify int Jimmy. See that? Hello. Here we go. Function Jimmy is not a type name. Right. Okay. But if I did If I did that, that's fine. Right, okay. Right. I kind of get it. Because, okay, so there's no type name for a function in general. Like an int is an integral type, right? It's an int. And, no, I don't know about that, actually. Well, I guess they'll be... I guess that... yeah, okay. No. It's complicated, alright? So that's fine. We've got an explicit... we've got an explicit thing there. Cool. That's explicit. And then we can use this. Oh no. It is type def. I knew it. And then we can have void Gumify to fun. Yeah. Okay. Okay, we're getting there. We're getting there. Of course, if I delete this, if I delete this comment line now, we're gonna have a red squiggle because this is a duplicate definition, right? Oh, how interesting. Ah! This I gotta tell you, this Halloween overlay is harder to run than Crisis. No joke. So let me talk about that while I try and understand what's going on here. Oh, they're different functions, that's why. I'm an idiot. Now they'll be angry, right? It's not angry. Why isn't it angry? I'm worried. Now I'm worried. Because these should be equivalent. The compiler, Visual Studio should be like, hey, buddy, hey. That's not right. So anyway, let me tell you about the Halloween overlay. It is very sad news that I moved up to 4.25.3 to do it. I thought, yeah, 4.25.3. May as well use the most up-to-date Unreal release in the engine, the stable boy, to do this thing, and it'll be great. You know, we already know 4.23 works fine. We already know, because I've exported full video game now, like 5 or 6 times from 4.23. And it, it takes, a couple of minutes, if even minutes, sometimes seconds. And I go to export this, which the sum total of this program is one emissive cube, which is a completely procedural textures. There's no texture. It's just the color magenta being output at value 1 emissive. So that means it doesn't give off magenta light, but you can see it in pitch dark as full magenta light. That's how emissive gain works, right? So there's no bloom. I took the vignette off the camera. I switched the camera to orthographic view, so everything was nice and flat and straight. And then I have one particle emitter that emits one of these every second. And there's 26 particle emitters, but they're all in one particle system. So I don't think that would be a big deal. And they're GPU sprites. And Epic go on and on and on and on and on about how GPU sprites and GPU particle systems are so efficient, so good to run. You can have thousands of particles on screen at any one time. Now this is approximately, I don't know, what, 30, 40 particles on screen? Because, you know, the rate, if you set the rate to 1, it's not actually one per second. There is some doubling up. And I don't really show the ins and outs of the Unreal Engine system. But anyway, just take it from me. It's about 30 to 40 sprites on screen at any one time. 30 to 45 sprites rendered, because some of them are clipped off the bottom of the camera screen and some of them are off to the side, but not many. I have it set up pretty clean, so, you know, you'll only get just about half a pumpkin head at the edge. Anyway, and that is consuming 70% of my GPU, because I have not rendered this as a program. This is running in an editor window. Sorry, no, it's running in a standalone window, which is why I could full screen it, which is why it fills the frame, which is why you don't see anything cut off, which is frustrating, because one, editor window will not fill the frame. Hold on, slam. No slam, a miracle. The editor window will not fill the frame. I can't run it in editor because that's an even smaller window, and all the sprites start to get blurry because the camera can't render things properly. There are some concessions, some cutbacks that Unreal Engine has to make in order for it to actually work. But yeah, this GPU sprite system, I don't know, this GPU particle system, sorry, I think probably would have been a lot more efficient if I had used a sprite sheet lookup table. Like, it has what is it? It's a UV sprite template or a UV particle thing. They use it a lot for animated sprites, for animated like clouds of dust that kind of poof out the Unreal Engine. But you can also use them to select from a range of individual things for the same emitter, which is essentially all I wanted. You know, I want some shit on screen. But I thought it's a lot simpler because I have individual images. I don't have a UV sheet that I can scroll across. I have individual pictures. They're all their own material. They're not even big. They're 512 square, right? So it's power 2, so it you know, good MIPS, easy MIPS. It's square, good MIPS, easy MIPS. They're not even anywhere close to 4K. You know, 512 is the biggest they'll ever be, so they're not large textures by any stretch of the imagination. They're about the same size as a texture in source. But somehow, somewhere, this tiny scene with one particle system, one camera, one magenta cube, does not render, does not output. You can run it in editor, fine. You can run it in a separate window, fine. You can run it in an editor window, fine. You cannot export the program to an executable file. I don't know what's going on. I mean, you can start the project going, but it just keeps going. Like, I left it for 25 minutes and it still wasn't done. And I'm like, this isn't a 25-minute job. This is a 25-second job, you know? When I made the snow filter thing for the Christmas thing last year, it was fine. It worked perfectly, quote-unquote perfectly. I didn't have really a beefy enough PC to run snow over the top of another game. So it's basically essentially like running 2 games at the same time. I probably should break away from using Unreal to do these animated overlays, really. Probably just record a video of it and overlay it like I do with the technical difficulties. There it is. It's just a video. Whoa, that's just a video file. But it was the rotational rate of the ring that I made in Unreal was such that I could subdivide it out to a 60 frame per second video, and you know, it links up perfectly and it loops perfectly. And it took a couple of minutes. it's a great effect. I'm pretty happy with it. This and the New Year's stuff and the Christmas stuff, I like it to be a little bit more. It's not really random or spontaneous, but like, have you ever tried setting up a random emitter thing to be the same, to loop? I don't know how you do that. I mean, I'm sure there's a way. I'm sure there's a smart person out there who could save me 67% of my GPU utilization right now. Sorry about that rant. Back to C. So I don't know what the fuck's going on around here. This is messing with my head. This is messing with my head. You know, I've been thinking, like, we do a lot of working through this book, which we are about a quarter of the way through, maybe. Yeah, we're about a quarter of the way through. We're on page 326 of 1399. So we're on episode 38, I think. So that's a quarter of the way through. We're going to be in like episode 150 by the time we're actually done with the book. And that's I dread to think. This day. Oh, so the interesting thing about this is Jimmy isn't a function type name, but Funk is a function type name for Jimmy. Oh, I see. Type definition. We're defining a type for the function Jimmy. So Funk is a type name for the Jimmy function type. I get it, right? That makes sense. That makes sense to me now. That makes sense to me. I get it. I get that one small bit of the giant, huge problem mess of spaghetti code that we've got here. We'll get there one day, I'm sure. But I was thinking, maybe we could have. I know, like 150 weeks straight of doing this. That's 3 years. Oh crap, that's 3 years. We're gonna have to start doing more C++, aren't we? More C++ or drop it altogether. I was just thinking about doing maybe some more practical programming, because I still have not finished that MIDI controller. The Arduino MIDI controller. Is it an Arduino? I think it is. You know, it definitely is an Arduino. But sketches me out, man. Thinking about the microcontroller, how it has a 22-pin I/O, and I'm like, is that simultaneous 22-pin I/O? Does it interpolate over those? But basically, the idea was to have a knob for scrolling menus and adjusting values, a button for selecting and going back and forward and stuff, a little screen that tells you what you're doing, and I have actually like 8 red LED 9 seg 1 2 3 4 5 6 7 8 seg displays. 8? Yeah, 8 seg displays. I guess there's 7 seg with a dot. But I only have enough muxes to run like 2 of them. But I'd have to program the mux. I'd have to program the mux per se. I have to program the Arduino to use the mux to use the 8 seg displays. But I was thinking, you know, I could have 3 of those in a line, and you know, that's 9 terminals per 8 seg. 9 times 3 minus 2, because 2 of those are ground. Ground can all be barred together. 9 times 3 minus 2. 9 times 3? 27 minus 2? 25? Actually, no, you know what? I think I might have enough muxes to do that. Bear with me, because that would only be 25 pins. 25 pins. No, I can't do it. I can't remember how many pins the muxes have. I think there might be 8. So I'd need... Oh, three muxes would be 24 pins. And then if they all shared ground, maybe I could do some fuckery there. Maybe that would work. Why am I thinking about this now? You're distracting me. I'm distracting myself. Returning a pointer to a function. As with arrays, we can't return a function type, but we can return a pointer to a function type. Similarly, we must write the return type as a pointer type. The compiler will not automatically treat a function return type as the corresponding pointer type. Also, as with arrays, array returns, by far the easiest way to declare a function that returns a pointer to function is by using type alias. What? Okay, no, I don't get it again. God damn it. So we've got PF-F1. So, okay, no, sorry. We'll start at the beginning. We're using type aliasing, using f equals int star int. F is a function type. And using PF equals int bracket star int star in. PF is a pointer type. That's fine. That's fine. I get that. But then we have PF-F1 int. What? You know, the boys on the forum, the girls on the forum, the people on the forum were right. This is this is not a great guide to see. This is a great reference if you need to look something up to see. But this is not going to teach you. It is literally just definition after definition, isn't it? To define f as a function type and pf as a pointer to function type. Thing to keep in mind, unlike what happens to pointers that have function type, a return type is not automatically converted to a pointer type. You must explicitly specify that return type is a pointer. I don't get what they're doing here in the second section. Oh, right, it's a function declaration. Oh, right, okay. Okay. No, I get it, right. It's a weird back-to-front function declaration of the function f1. Right. So they're declaring f1 directly as int star f1 in a lot of brackets. Reading this declaration from the inside out, we see that f1 has a parameter list, so f1 is a function. f1 is preceded by a star, so f1 returns a pointer. The type of that pointer itself has a parameter list, so the pointer points to a function. That function returns an int. And we get back to why. This is obviously something that's used a lot, because we're on page 300 and they're not talking about how do you move across a two-dimensional matrix. They're talking about how do you get a pointer to a function. How do you declare a function that returns a pointer to a function type of a function that has a function as its fucking argument. Silly! At least you've got ghosts to keep you company. I can't even see them unless I look over to the reference monitor. No, today I will be splitting the Unreal segment away. Like, I tried it out for a couple of weeks doing the C++ and then the Unreal like directly after. I didn't enjoy it. It was, I'm gonna be big honest with you gentle friends. It was better for average viewership, which is, you know, profits, but I didn't enjoy being sat here for like 3 hours straight, just mashing the enter key while my PC tells me no. You know? And what with last night's debacle with Unreal and this overlay and it taking up 99% of my GPU, I'm gonna have to just veto doing Unreal for as long as I can today. I think I'll probably get onto it around about 11, which is way after its schedule. I think it's scheduled for 5 usually, but I've got some stuff to do, and I don't want to see Unreal today, but I will see it because it's going to be Bubble Man, and Bubble Man is a very, very fun game to work on. I'll try and iron out some of the bugs. Maybe we can have a week 30.a snapshot. Because at the moment, in the rendered game, I don't know, I'm playing it in oh, hello volume key. Playing it in editor, the coins are fine, but playing it in the rendered game, the coins are not fine. They disappear before they even hit the floor, which is not good. So we can't return a function type, but we can return a pointer to a function type. Do you know what might be cool? I might start. A friend has very generously bought me a Vampire Counts unit from Citadel Miniatures. The Fiend. I might build that on stream. Maybe later. I have time. Probably won't have time. You know I'm not gonna have time, am I? Anyway. Back on with this. See if we can understand this chapter before I log out. Maybe if we write some of this code out, it will Unreal, sorry, no, Visual Studio will tell us yes, and it will tell us no, and it will. So this is the code they have. Oh. Oh. Haha. Silly coder. Forget your semicolon again. Should just put a semicolon at the end of all the lines, really. That would help everyone. I'm waiting for the rage. I'm waiting for it. I'm waiting for embracing. Embrace for impact. It didn't come. So then we've got PF F1 int. We got F F1 int. says that's an error, right? That is an error, okay. F is a function type. F1 cannot return a function. Then we got F star. F1 int. Oh, hello. Cannot overload functions distinguished by a return type alone. Hi. Oh, green. Hello. Function definition for F1 not found. Function definition for F1 not found. Okay, so, okay, right. Working backwards. We did a bad. Cannot overload functions distinguished by return type alone. Let's delete that. Let's get that out of our life. We don't need that. Function definition. Create definition of F1 in salesdata.cpp. You mean source.cpp, right? We're here. This is salesdata.h. You okay, Visual Studio, buddy? So it's got this written down. Okay. Right? Whoop. And that's fine. That's not fine. Function definition for F1 not found. So, yeah, F1 is a function. Okay. Nice void, bro. And now they all go red. I make a function definition, and they all go red. Cannot overload functions distinguished by return type alone. Go on, tell me. Take me to... In C++, function overloading is not bound by return type of the function. Two functions are said to be overloaded only if both functions are present in the same scope. The names of the functions are same and differ only by number and type of parameters we pass. Okay. So the problem that we have here is that we're trying to return the pointer type to F1, but F1 does not return a pointer. If I were to weave some on the clacky keyboard, no, that's even worse. Declaration is incompatible with PF F1 int declared at line 136. Okay. Okay. So that was a no. Okay, it's fine. I understand that that's a no. Taken. My brain is just disintegrating at this moment. I understand what it's telling me. I understand what it is trying, the words that it is given to my face. We'll just work with one of them right now. Okay, PF. In fact, we won't even work with PF. We'll work with the explicit function declaration for cannot overload functions distinguished by return type alone. Is it just because this? Can I just, yeah, bro. PF F1 int, PF F1 int, F1 int, F star 1 int, okay, int F1 int. Make it actually a function. Returning a pointer to a function. Of course, we can also declare F1 directly, which we do as okay, so this function definition, not for F found. Can I search that one online? Sure. C type of int star star int star int star 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 Stack Overflow. Whew, that's a lot of fucking shit, isn't it? How to check if input is an integer in C++. Yeah, just copy signature F of F1 to clipboard. Wait, what did it say when we had this not in here? Did it say function definition? The function definition, right. That's a function declaration, but we don't have a definition. Right? So if we... That's a lot of red. Okay, no, that's that's not how you do that. The green's gonna go away. The green's gonna go away. Green has gone away. Green has gone away. Right, okay. So the function declaration is the top bit. The function definition is when you have the body of the function. Okay, so if we strike that out and we bring one of these back and we, you know, we do something like that. Return value does not match the type function type. Whee! I don't get it, because they're obviously not. They're not meant to have this return. They're meant to return a pointer to the thing, to the. Making me so angry. I just don't get it. You know what? Next week I might get it. Next week. Oh, we got an orange. We got an orange label. Oh, we're dropping frames. Oh, we're dropping frames due to rendering lag. I wonder why. With that, friends, it's been a blast, but I gotta go. I gotta go do real things that I understand. I'll think about this and it will torture me for the next week, I'm sure. But yeah, thanks for coming up with the live video. Thanks for coming up with the video on demand. If you can't watch the video on demand, I will see you, as always, in the next episode.